A few weeks ago, Beau and I went on an adventure unlike any other, a trip to Panzer Farm in Poland. We've seen incredibly rare parts, breathtaking restorations, and dived into the details of how Maybach engines can be rebuilt. But what does this mean for us at Oz Armour? How will this help with any of our own restorations? Well, in this episode, we are proud to officially announce our collaboration with Panzer Farm on our Tiger 1 restoration project. And we have been given the exclusive opportunity to show you the amazing capabilities of Panzer Farm. So sit back, relax, and enjoy the finale of Workshop Wednesday, Polish edition.
So I can show it.
Oh wow, this is a special room.
So here is the Stuck gearbox, which is totally disassembled. The housings are scanned, and we are going to make complete new Stuck gearboxes. And it's for Panzer Farm, completely made in Poland.
Wait, that's not original. This fully made.
It's fully made. It's now going to you in the container. Also, some 4 of them, I think.
Oh.
What could they be for?
I wonder.
It's like the casted, so also made all the documentation on it. Later in 10 years we can also produce. So when we produce something, we make like multiple, even we make some for stock. Very often some guys ask, do you have it? So, and also makes sense to make like more than we need because it's like one work, let's say.
It's easy.
That's MG, but Yugoslavian. And
Oh,
this is
right.
the T55-A. These both are deactivated. These one are here because I 3D scanned. For this work, for designing, for reverse engineering, we have the metrology quality 3D scanner. So on 1 meter it has 0.02 millimeters. Of course, the best way is to have the 3D scan and the part at the table. But sometimes you can just go to the museum, scan something. We can scan complete vehicles or guns for the purpose of designing plastic models. Yeah?
But enough about scale models. Let's check out the Tiger 1 gearbox Panzer Farm are preparing for production.
Here are the Tiger gearbox housings on which we are working now. All these blue boxes here are the parts from this Tiger gearbox and steering gearbox. So it's more than 1,200 parts. Each part you have to make the 3D model, you have to make 2D drawing, production drawing. Hopefully in 1.5 years we will have the first prototype of the Tiger gearbox. So the Tiger gearbox is going very well. I mean the housings are, half of the housings are already made as prototypes, the castings. And next month we cast this piece, which is quite advanced piece because you have the steel pipe where the oil manifold goes, yeah? Because the casting, especially the iron casting, is not always perfect, so the oil could go through all the holes it can find. So they made steel manifold. These are the housings for steering gearbox. The steering gearbox is made of cast steel. The main gearbox is made of cast iron. Here is the diagram of the hydraulic system. So really complicated as for these times, really advanced technology.
For 1930s,
yeah,
1940s.
Yes, yeah.
Amazing.
For sure. It's very often less complicated in nowadays cars. First of all, we want to make complete documentation, then start producing. Yeah? Wow. This is the model for the Tiger idler wheel. The core for the inside part of the wheel is here. So the form will consist of I think maybe 20 cores. So and then it makes the final shape. The inserts, which you will change because in the wheel, in some places there are different numbers, so you have to change the numbers. This is the original number of the part. So we have these numbers from the pattern, but we have also found the original parts list in Italy. Oh, wow. So we have all the parts numbers. That's the 3 letters of the factory, and 44, of course, it's 1944. DKR is, I think, if I am right, it's Henschel factory.
And that's why we don't cast things.
Yeah.
People ask us all the time, why don't we cast something.
Yeah,
Why do I fabricate it?
Yeah. So that's why we cast, because it's still possible in Poland. The environmental rules can easily destroy foundries. We still have some foundries to work with. That's why we make it here. In United States or by you, this will cost 10 times more. Won't be possible. The Tiger steering gearbox gears, new gears. It's manufactured by our friends in Germany. Already for the steering gearbox, if we finish the castings, we can try to assemble the prototype. That's the hydraulic powertrain for the turret, so you can rotate the turret left and right, and also the speed of rotation. This is just the rough casting at the moment, but also we are designing complete assembly. Panther clutch housing, also they are always blown, so that's the pattern to make new ones.
Since no production drawings survive, Panzerfarm have had to make their own. But surely this takes forever. Well, thanks to state-of-the-art 3D scanning technology, it's now possible to take extremely precise measurements in just a few minutes, as long as you have an original part.
When the scanning is not correct.
The first part of the process is scanning the markers, the points that allow the position of the scanner in reference to the scanned object. So here you can see these dots. He is measuring the position of the dots, and then using these dots, it knows where it's located in reference to the arm. So you can see on the computer how fast it's getting the data of the surface of the scanned object. Now I have the resolution of 1 millimeter, so it won't give a lot of details, but it still has the accuracy. In this part, the accuracy is about 0.02 millimeter. You can measure everything without the measuring tools. So we use the 3D scanner for scanning the mechanical parts we make, but very often we also use it for the plastic modeler company just to scan the things they want to make. To get these shapes, you need to use the geometry or use the special tools to measure the roundness. It was 5 minutes. Even in this time, you can get a lot of details. To make it 100% accurate, you need to use the photogrammetry before, so the process normally takes longer, but enough to save a lot of information about this detail. It's few minutes. All the things we make, we scan to use for the design, but also, as I told you, to inspect later after the production.
It would make things easier, Beau.
Yeah. Then I wouldn't know what to do with the picture afterwards. I just look at it.
Yeah.
A 3D scan is good enough for a scale model on its own, but for working parts, exact precision is necessary.
Firstly, I 3D scan parts, then reverse engineering it in software here on computer. Next, I'm doing all the moldings and models for casting it, things like that. Then machining it. First, we have a mesh file, so 3D scan of casting, and then we are building a rough model of it.
What we do, we use the 3D scan only as reference to build the parametric 3D model. That's a good example. We 3D scanned the Tiger transport truck, and this is the exact 3D print of the STL file without making the parametric model. This is, after our work, the parametric model. We can compare and see if there are some mistakes. So that's why we print. You can't see every detail in the computer, so sometimes we just 3D print our model and the original thing. So we can compare, see if everything is right. That's the central mechanism for the Tiger. In early Tigers, it was also power for the bilge pump. Here is the main shaft. It gets power from the engine and gives to the main gearbox. Small gears here. It gives with the shaft the power to the hydraulic pump, which allows to rotate the turret. That's so at least 1 gigabyte if you want to have it in high resolution. That's what we need, because we need to measure exactly the axis distance and so on. That are the first gears that we got yesterday from the factory. It's completely new made. A few sets to later fit in a housing we cast and machine.
Rough model here. Without all the fillets and drafts. Then we are going further and further.
Wow.
This is with all
Stock material,
Stock material.
for casting, so
Yeah,
you
for
have to close small holes, give additional material to then machine the casting. We need about 20 or more tools to make all cores for the casting, all the form.
form for the clutch, this part. We have to do something like that to replicate that.
So all the gears, all the inside has to be scanned, made. We make the free design, then do drawing. So that's big work.
Big part and small parts.
Yeah, big work and small parts. Yeah.
So it's not all of the parts, but
Most of
most
them.
of them. Yeah.
But you only do it once.
Our main aim is to have the full documentation to make it always. And in the future, even if the technology change to produce,
The model
we
will be
still
the same.
the model will be the same. The documentation should be the same.
This
something
is
like-
amazing. And this is just the turret traverse.
Yes.
Yeah. So that's one part of the Tiger. We already have casted these housings. Now they are waiting for machining. It's initial alignment of the Tiger gearbox. You can open it. So still like initial, still a lot of work to do in it, but you can see how complex vehicle is that. So it's the gearbox, and the steering gearbox is 1.5 ton of like only mechanical parts. Hydraulic steering for the gears, so you don't steer manually. You steer with hydraulic. So you choose the gear, and it's the hydraulic change the gears for you. They invented this system. It allowed also to turn in one point, one track forward, one backward. So quite complicated. As I told you, the gearbox is like, even for nowadays, it's huge job and perfect engineering.
Yeah.
Totally incredible. This was for sure the most jaw-dropping part of our brief visit. After Daniel finishes the 3D designs, it gets sent to the programming team at Panzer Farm's CNC machine factory, where Michael's brother Martin takes over production.
Mostly these are 3-axis and 5-axis CNC machines. This is our biggest machine, which is 4 by 2.5 meter. So you can manufacture a small boat on it. This is the second very precise machine, which is 3 by 1.5 meter, and it's also 5-axis machine. And the most precise in here, the smallest, but also 5-axis. 3-axis, it can go X, Y, and Z. And 5-axis is additional 2-axis rotation. So you can do the simultaneous milling without stopping. Now in the process of milling the shape, this is one of the last processes. After milling, it all goes in here, where you can see all the elements. It then goes into this specific shape. The thing you saw there, this is the second part, and this is the base plate. Then this other goes on here, clamps, fixing everything together. Mostly is like few hundred elements per fixture. It all depends on the complexity of the part. The last step is to measure and adjust the fixtures after assembly, so that overall we have tolerances we need, and also we have a measuring protocol from it. You can see here how the measuring is going. The program knows where it sits on the table, and after that he measures. If there is anything wrong with it, then we need to adjust the fixture by, for example, changing the position of the hole. So there are many factors in it. Mostly these kind of gauges goes without any adjustments, but when we have assemblies with hundreds of elements, then we have to adjust very thin plates with just aligns a little bit.
Michael would want you making tank parts 100% of the time, right?
The tolerance is of course not as precise here. Now we are in the middle, so we make something for the Panzer Farm and we make also for our clients.
During our visit, Michael showed us an example of one of these fixtures being used for the Tiger One gearbox manufacturing.
So this thing is the oil manifold for the Tiger gearbox, also for steering the gearbox, because the Tiger gearbox is steered by hydraulic. So we made the tools to first bend the pipe, each pipe, and then on this fixture we weld everything together, and heat treatment, and at the end we will put it once again on the fixture, check if the position of the fittings are right. Then we put in the casting form and we put the cast iron inside the form, and it will give us the final casting. It was first designed to allow the bending of the old pipes and then to weld them also. So quite a lot of work to just make the oil lines, but all of them will be the same. Casting is so like complicated and expensive, then better to make this oil manifold precisely to not break the final casting. Before next steps, we need to prove the joints are tight and if it's not leaking. It has the pressure of oil up to 17 atmospheres, and during the casting it will also get the heat and a lot of pressure, so we have to test few times to check if it will work or not.
I'm sure it will work.
Hopefully. That's the first time we make such complicated thing.
It's very early days and there's still a lot of work to do, but we already have some parts on their way to Australia. It will very likely be a few years before we're ready to disassemble our own Tiger and begin the long process of making it a runner. But the tracks are in motion, and you can rest assured that any updates will be posted right here on our channel. But that's all we have time for today. Join us next Wednesday for your weekly tank restoration fix. So until then, I'm Kurt from Armour, and I'll see you on the next one.